Hello, my name is Zana Shahsawary and welcome to my tutorial on airbags and the chemistry of it. You must be wondering, what is an airbag? An airbag, by definition, is a vehicle safety device. It is an occupant restraining consisting of flexible envelope designed to inflate rapidly in an automobile collision to prevent the vehicle occupants from striking interior objects such as the steering wheel or the window. The airbag was invented by John W. Hendrick in 1952. It was originally used in World War II for plane crashes. Now, the question you must be asking yourself is, how does an airbag work? People most commonly think that airbags are inflated by some sort of compressed gas source. This is actually not the case. Airbags are actually inflated via 3 stimulus chemical reactions. But before we get to know that, I'd like to discuss how airbags know when to inflate. When a collision occurs, sensors at the front of the car detect it and sends an electrical signal that sets the chemical reactions in motion. These reactions are so fast that it occurs in 0.3 seconds. The first reaction that occurs is a decomposition reaction. Sodium azide decomposes to form a sodium metal and a nitrogen gas. A very small amount of sodium azide is needed to provide enough nitrogen gas to fill the airbag. The balance equation looks something like this. The question you may be asking yourself is, isn't sodium metal highly explosive and highly reactive with water? I'll be explaining to you in the next slide. Yes, it is true. When the sodium metal reacts with water, it forms sodium hydroxide. If this substance got into your eyes, nose, or mouth, it would be quite painful. But the airbag manufacturers are very smart. They have added other chemicals into the airbags to remove the sodium metal. That is where the second reaction comes from. It is a redox reaction and is shown below. But as well, the potassium oxide and sodium oxide are highly reactive as well. Well, that is where the third reaction comes in. 2 metal oxides are removed from the gas when they react with the silicon dioxide. This equation produces alkaline silicate, which is a stable form and therefore not dangerous or harmful to other occupants of the car. So, that's it, you may ask? Well, there are some other things I'd like to mention as well. First, sodium azide is actually very toxic in its solid form. However, in a car, and it's carefully placed and concealed in its compartment, and it is very unlikely that the driver will be exposed to it ever. Also, other alternative chemicals are used for the same purpose, notably helium and argon gas. It should be also mentioned that the gas laws do affect the chemistry of an airbag. However, I'd like to stick with the chemical reactions that make things possible. With that, I'd like to say thank you, and thank you for listening, and congratulations! Now, you know the chemistry behind the airbags, which makes drivers' lives safer every day.